Hello there. In the last video session we identified the centroid for the semicircular when a wire is going to be bent in a semicircle. Now the question is that find the centroid of a uniform wire bent in the form of the quadrant of the arc of a circle of radius r. So it is clear that it is going to be a wire is going to be bent in a quadrant. That means 1/4 of the circle only they bent, and it has a radius of r from its centroid, from the center, and we need to find out the centroid. So then how we are going to be proceeding with this part? In the previous example also we do have taken. So that means he has given the r is the radius. So the radius he has given, and the total length is I am going to be taking. That's going to be total length. That's going to be the perimeter length we are going to be taking from there. And similarly, other parameters we are going to be considering with the help of this while assuming this x coordinates as well as the y coordinates. This is the y and this is the x quadrant. Once we are going to be getting, as we know that the radius is going to be existed here is the r. R is going to be the radius we do have. And similarly, once we have these two parameters, then we need to go with the division of the given object into number of elements. So for this part, I am going to be taking, this is going to be your element. It means we need to do this into the number of segments. For the time being, I am going to be taking a very big element in this case, so that I am going to be projecting to the origin. So this is going to be the O. So then I am going to say this is the P and this is the Q. So then what will happen in this case? So with respect to this part, it is going to be making an angle theta, and with the elemental strip, the displacement is going to be your d theta. Right? The same elements we will have taken. At the same time, this elemental strip is going to be, suppose the total length of this one is going to be existed at a distance of xc, and this is going to be your yc. We don't know exactly where the centroid, but I am assuming that it is there at this point. So then what is this point r is going to be? This is going to be another part p, q, r if I am going to be saying. So then the distance between o, r is going to be your x. That means x is going to be the distance located from the y-axis is going to be your elemental strip. And similarly, the elemental strip is going to be located with respect to the x-axis is going to be your y. Right? So x and y are going to be the distance located of your elemental strip, and xc and yc are going to be your centroid of this, the total length of the wire. So in this case what will happen? The theta is going to be angle of elemental strip with respect to x-axis. Next, d theta is going to be, the d theta is your elemental angle of elemental strip, and xc and yc are the centroids with respect to xc and yc, centroids with respect to y and x-axis. And similarly, we do have the x and the y are going to be the elemental strip is located from the y-axis as well as the x-axis. So from these parameters, we are going to be trying to find out the centroid. So now we are going to be finding the centroid with respect to the y-axis. That's going to be xc. I need to find out. How to find out this part? Already we do have a discussion about it. That elemental strip we have taken that part. So that we are going to be considering over here. The total length already is available. That is located at a distance of xc with respect to the y-axis. That's going to be L into xc we do have. And similarly, the summation of the individual, the forces we are going to be taking, the moments of the individual forces, that's going to be integral. What is distance it is located at a distance of x, it is going to be located. That's going to be x into dl we are going to be multiplying. So now in this case, what is the x and what is the dl we need to substitute so that we will get it. So from this triangle, I am going to the triangle OPQ if I am going to be taking. So in OPQ what will happen? This is going to be your dl, and this total length we are going to be called the radius. So that in this case what will happen? I am going to be taking the tan d theta is equal to dl by r. So dl is equal to r into d theta. I will take it. Right? So in this case we are going to be getting, and similarly in this case what is the formula? That's going to be 0 to 90 degrees only it is going to be spreaded. So in this case the dl is going to be spreaded 0 to pi by 2 only. If I am going to be substituting in this equation that integral 0 to L, then 0 to pi by 2 and r d theta. Right? If I am going to be taking in this case r is going to be the constant terminology, d theta will going to be your theta. So then I got it from the pi r by 2 I got it. So that's the total length L is equal to pi r by 2. So that I am writing L is equal to pi r by 2. Right? So we have calculated L is equal to pi r by 2. That means the total perimeter length of the wire, bent wire, is going to be pi r by 2. Now we need to find out the x value. So x value, how we are going to be taking. So for this one I am going to be taking the triangle OQR. The triangle OQR. So in this case what will happen? It is going to be making an angle theta with respect to the x axis. So then OQ and R I have taken, it is located at a distance of x and this one. So we need to find out the x one. So this is going to be your OQR, right? This is the y distance, it is there from the x axis. This is the y axis, x distance is there. It is going to be making an angle theta. This is the R. So I want to define the x or y in terms of the R as well as the theta. So that cos theta is equal to x by r. R is equal to x cos theta. Right? So that that x is equal to r cos theta. I got it. Then I'm going to be substituting in this equation. So in this case, what we got it? That's going to be dl is equal to r d theta. We got it, and similarly that L xc is equal to integral. So in this case r cos theta, that's into dl is equal to r d theta we are going to be taking. So in this case theta is going to be the variable, that's going to be 0 to pi by 2. So that's going to be 0 to pi by 2 means here r is going to be your r square, integral 0 to pi by 2 cos theta d theta. So if I am going to be substituting in this equation, what I am getting, that r square. So this is going to be your sin theta 0 to pi by 2. So that's going to be r square sin pi by 2 minus sin 0. Sin 0 0 over here. So then sin pi is equal, pi by 2 is equal to 1. So then I am going to be getting from this part. See, that's going to be LXC, that is equal to, this is 0 and this is the 1. So this is going to be your 1. So that's going to be, I am getting the r square. Next, XC is equal to, what is the formula we do have? That's going to be r square divided by, what is the L is equal to? Pi r by 2. In this case, r will cancel. This denominator will go to the numerator. That's going to be 2r by 2. Right? That's going to be xc is equal to, we got it, 2r by pi. So that's, I have written xc is equal to 2r by pi. Now we need to find out the centroid with respect to the x-axis. So then how could you write it, the centroid with respect to x-axis? That means it is located at a distance of yc of this elemental strip, or the total length of this one, and the y is going to be the distance from the x-axis to this elemental strip. That I am going to be taking the theorem of Varignand, L into yc, that is going to be equal to integral y dl. I want to multiply because it is located at a distance of y, right? And with this one is the dl. So how could you find out dl? Already we do have, that is the r d theta, and y how we are going to be calculating. So from the same triangle OQR, if I am going to be taking, then sin theta is equal to the triangle OQR. So sin theta is equal to y by r. Y is equal to r sin theta. Right? So then substitute in this equation. So y is equal to r sin theta. Similarly, dl is equal to r d theta. So this is going to be 0 to pi by 2. So further simplification, r square minus cos theta 0 to pi by 2. So what is the values we are going to be getting in this case? So that's going to be r square minus cos pi by 2 minus of minus cos 0. So from this one, cos pi by 2 is equal to 0 and cos 0 is equal to 1, and we are getting the positive value. So from this one, LYC is equal to r square, I got it. The YC is equal to r square by L is equal to pi r by 2. Then finally r will going to be cancelled. Then finally that's going to be 2r by pi, I got it. Can you see? YC is equal to 2r by pi. XC, YC also we got the 2r by pi. Means this is going to be located at a distance of XC is equal to 2r by pi. Suppose if you are going to be taking the values of the r value, suppose, then we will get where it is going to be exactly centered. This way we have to calculate the centroid for the elemental strips. So in this case only one dimensions we have taken, that means 2 dimensions we made it the options by assuming that the body is a homogeneous uniform cross section. That means the density and area is going to be constant, only the area or the mass is going to be distributed along the length of the member. So on this basis we have solved. That is the centroid with respect to y axis, centroid with respect to the x axis.